Hi, today we're going to talk about friction and look at a friction lab. When you talk about friction, we're talking about a resistive force that is preventing an object from moving. Remember, friction never caused anything to move. So what we're going to be taking a look at here today is this block system. This is a cart, can run down this track. It sits on this track very nicely and runs up and down with its wheels. But I'm going to flip it over and place it on top of this friction block. And this friction block has a couple different surfaces which we'll test out. I'm going to place this cart on here. When I take a look at this, we are going to take and hang a mass off of this end. Gravity will grab hold of that mass, pulling it down. The weight of this mass will pull down, and it'll pull along this string over to the block. The friction will act on this block to at first hold it in place. It's static friction. And then once we have added enough force on this side to overcome the friction, the block will begin to slide. As you are aware, friction, the kinetic friction is generally less than the static friction. So as the weight is added at this end, this cart will hold, and then it'll take off in an accelerating pattern. So to test the difference between static and kinetic friction, we'll start off by placing weight on there and to see when it starts to move, and then we'll give the block a tap to figure out where the kinetic friction exists. To optimize your time during this activity, I'm going to demonstrate a couple different trials, and then I'm going to provide you with some additional data in the spreadsheet that you see here that I collected off camera so that you can complete your lab. So in this lab, we start off by taking a look at, we actually start off in table A by taking a look at static friction. And so I place the cart on a balance, and I find out that the mass of the cart and the block would be 620 grams. So I'm going to record that. The data table you're looking at does say to record that in kilograms. So I will record that as 0.620 kilograms. We are then going to take some mass sets, as I mentioned, and we are going to start adding mass to this side until the block takes off. So I'm going to start off here. I have 20 grams. Not enough. Okay, so now I'm going to add 50 grams. Still not enough. Then I am going to add 50 more grams. Still not enough. Now I'm going to add 50 more grams. Oh, it's starting to move. You can see it accelerating here. I want to validate that point. So I'm going to go back to the same start point I had, right around the 100 centimeter mark, 1 meter away from the end. I'm going to go back. 50, that's a 50 gram increment. So I can take the 50 off, and it is holding in place. There's a weight pulling down here. Friction acting between the surfaces, pulling back here. And so now I'm going to add, instead of adding 50, I'm going to add a 20 on here. I have some 20s and some 10s. So I'm going to add a 20 on here. Not enough. I'm going to add 10 more. Still not enough. Oh, there it goes. 10 more to go. There it goes. So just one more time to make sure that we're right, I'm going to take 5 off. So I'm going to flip out that 20, that 10, that last 10 with a 5. I know that this is going to bring some error in, but what I usually say is to get within 5 grams. We could go on with this pattern all day long. And as you know, friction changes. So as that block slid down across here, it was polishing it a little bit. The level of friction changed a tiny bit. So when I let go of this, that 5 was still too much. We're going to go back, take that 5 off. That puts us back to, before that, I put a 20 on. So now I'm going to take the 5 off, see if it holds. Doesn't hold. I'm going to take the 20 off, put 5 on there. Again, I want to go back to that same start point. It's going. Take the 5 off. We might have been at the right spot with that 20. And so that's one of the things you have to do. We have to go back through this and validate our numbers. And then it holds. So the holding friction here will take off the entire mass hanger. The mass hanger itself is 5 grams. I have a 50, and another 50, and a 20 to start. So ultimately it should be around 125, but we'll get the exact value. There might be some dings in these masses. And when I put it on there, it comes out perfectly to 125. Great. So I will put the hanging mass as 0.125. And so that's your hanging mass. I'll do this again by adding 200 grams to the surface. And then I'll add 200 more grams and do it a third time. I'll do that off camera. I will definitely provide you the data. I'll place it here in this graph. The second thing I'm going to do, while we're doing static, I'll do it all in one shot. I'm going to move down to table B1. And in table B1, I'm going to take this first was felt on aluminum. The next is going to be the clean wooden block on aluminum. And so I will place the clean wooden block on aluminum, same spot. I'm going to come down here and we will see what it starts. Make a prediction, make a hypothesis where you're at. Do you think it's going to be greater coefficient of friction or less coefficient? Is it going to start sliding sooner or later? So we will place this on here, and I'll start by placing a 50 on. It holds. Place another 50 on. It holds. Place on there 20 more. It holds. Place on there 20 more. Still holding. Place, here we go. So you can see it, it's just starting to move. And that happens. This was shaking a little bit over here, and that actually adds a little bit of centripetal force. We'll talk about that at another time, but that got it going. Boy, that's really close to being kinetic friction. I think that a little bit of extra push may have done it, but I'm not super happy that super happy with the fact that it was swinging. We'll see if that actually had an impact on it. Nope, it looks like that did not actually. So I'll take off this last 20. I'll put a 10 on there, see if it'll hold 10 grams. It's going, so I'll take the 10 off. Put a 5 on. And that held. So we now have the start for the wooden block. And so the mass did not change. I just flipped that block over. So for part B1, which is the static for the different block, the mass did not change. So it's 0.62 kilograms. But the hanging mass did. We're at 130. So that's a little bit bigger. Not much, but it's a little bit bigger here. And so we get a different coefficient of friction. We'll do this experiment again with 200 and 400. We'll see what happens. See what happens with that. The next part that we're going to do is we're going to flip this block over. Again, we'll go back to the felt. And this time, I'm going to give the block a tap. So I'm going to start at about 100. I already have a rough start point. We know that the kinetic friction coefficient is going to be a little bit lower than the static. So I put it on there at about 100. I give it a tap. it doesn't want to move. We're gonna add to it some more weight. I'll add it to it 10 more. I give it a tap. Another little tap. Oh, it's close. I add to it 5 more. While I'm giving it the tap, it's overcoming the static friction, so we're moving into that kinetic friction zone. And there it goes. You could probably see it from home. It is moving. My finger is being held in place, and it is moving at a nice constant rate, nice and slow. You can see it speed up and slow down. It does give a little bit of a acceleration, deceleration at some points to cause it to, because the surface isn't perfectly smooth. In fact, I just stopped at that point, a little sticking point there. But we're going to go with the value that's on here, which should be about 115 if my calculations are correct. 120. So it's a little bit lower. As we said, it's not a bunch lower. Again, the mass of the block did not change. And so we can see that there is a different coefficient of friction for static than kinetic. We're going to do these calculations. And I'll show that in another portion of this activity. I'll do all the calculations with you next, so at the end. So what we are going to do now is the last part of this, which is table C, which is to find the angle of slip. So to find the angle of slip, this is very tricky for me to do by myself. There is an inclinometer located over here on the track that will tell me the angle of slip. And so I'm going to take the block and to take the paper clip off of it. So I just have the block, same side felt. I'm going to place it on here, and I'm going to slowly lift this up. And notice that it doesn't move. At this point, the weight is pulling down. The parallel force exists because there's an angle. There's about an 8-degree angle here. And so there's a parallel force, there's a normal force. As I lift this up, the parallel force becomes bigger, the normal force becomes less. I keep lifting, I keep lifting, I keep lifting, and then, oh, there it is. Right there, it starts taking off. And so at that point, I'm going to try to hold this steady. That's about 17 degrees. That is the angle that I will use in the next part of this activity. Part D, what angle did it slip at? 17 degrees. Again, I will repeat this 2 more times with 200 and 400 grams added to the top of the block. With this data and the second part of this video, which shows you how to put it together mathematically, you will be able to answer some questions and complete the lab activity. If you have any questions, as always, don't hesitate to ask. Have a wonderful day.